I hope that you're fine. Welcome to another session of Robotics Lab. In the previous lab, if you remember, that we learned about how to create a ROS package. And we used these commands here, and then we created a folder, and then we used a command called catkin make to build this package. So let's see again where our ROS and ROS package is located. Okay, so in the home folder we have created a catkin workspace. This is a folder where we will develop our new ROS packages, and then in this workspace we have further 3 folders. One folder is SRC, and in SRC folder we have created a package called beginner tutorials. Okay, and if you enter in this package, we have an XML file, TXT file, and then 2 more folders. Then we used this terminal. We enter a command here, catkin make, then it created a similar level of executable file in the devel also. So here you can see it has, after catkin make, you have here also some files, and also in share you have beginner tutorials. Since we don't have actually any Python code or any C++ code executable in our SRC folder package here, we don't have any executable code. That's why we cannot really execute it. Okay, but later we shall also enter here some C++ or Python code, and then we shall see how we can execute it. So this was our package that we have manually created, and then we told the ROS where the package is located, and also we learned where our ROS is installed. If you remember, if you go to other locations, then if you go to computer, and then you have to go to this OPT folder here. So here is your ROS is installed, and if you go to Noetic, and you can see there are bash files, and there are some binary files, and also libraries. And let's open this share and see what packages we have there. So as you can see, there are ROS is already equipped with a lot of number of packages. So for example, let's see this one, camera calibration. If you have a camera, you can use this package to calibrate your camera. And then other important package is catkin. So this package is used to build an executable code from your package, like we did last time. Then very important packages, for example, we have here so this depth image. This is for Kinect cameras that can measure depth also, and this is for OpenCV for image processing. And then we have different kinds of filters here, and then we have simulator. For example, this is a simulator, built-in simulator in your ROS. This is called Gazebo, and you can use it to simulate different robots. Similarly, there are a lot of packages here that are available, and if you want to search any package, you can maybe type your alphabet. For example, this package turtle sim, if you double click on it, it will open this package and the subfolders of this package. Okay, so this was our brief overview of the robot operating system packages, and then we now go to our today's work, what we are going today. The last time we have completed till here, we have seen that how we can navigate the ROS file system, how we can use catkin make to build the package, and today we shall further see what are the ROS nodes. So, this tutorial introduces ROS graph concepts and discusses the use of ROS core, ROS node, and ROS run command tools. So let's see how we can do that. Okay, for this tutorial we shall use a lightweight simulator. To install it, run the following command. Okay, so for a small simulator we need to install it using this command. What you have to do is to copy paste your command here, and then here in the place of distro you have to enter the name of your ROS distribution. It's called Noetic, and then press enter. Then you have to give your password. It is held by process this. Be aware that removing the log file is not a solution and may break your system. Unable to require that dpkg fronted lock. Okay, let's try one more time. Okay, so we shall just ignore this this error, and we just move to our next step. So quick overview of graph concepts. We have, so in the ROS environment we have nodes, we have messages, topics, master node, ROS out, ROS core. So what are the nodes? A node is an executable that uses ROS to communicate with other nodes. So this means that any executable that you write for your hardware or any of your program it will be a ROS node. For example, let's say you write a Python code or C++ code that gets input from your mouse, and then it move your cursor on your screen. Then this will be the code and the package that you make for it. It will be a ROS node. Okay. So there can be many ROS nodes. For example, one node for your mouse, one node for your keyboard, then one node for your maybe any sensor from your robot. For example, let's say infrared sensor. So you write a code here, you first make a package, write a node here using C++ code or something, and then this will be your one node. So in a robot there are multiple nodes. One node for your sensor, one node for your actuator, one node that control your robot. So these all nodes will communicate with each other using robot operating system. Then we have messages. So what are the messages? ROS data type used when subscribing or publishing to a topic. So messages are, you can see a space, a memory in your ROS environment where you can publish or you can subscribe messages. You can get messages from other nodes, or you can also publish your messages. For example, if you want to get data from your infrared sensor of the robot, so what will happen, the infrared sensor of the robot will publish data to your specific will send this data using messages to your ROS, other nodes of the ROS. Okay, and later we shall see what type of data they used. So it's messages is just like it's a data type. Okay, it's a special type of data that node use to transmit their information from one place to another place. Then we have topics. Nodes can publish messages to a topic as well as subscribe to a topic to receive messages. So what happens is that here, so I told a little bit about topics also in messages. So what happens when your infrared node of a robot want to send messages to your controller node? So what will happen? First, it will publish the data into a specific topic. So what the topic is just a temporary space or memory where the node can send or publish its data. So the infrared node will send data to a topic, and then the second node, for let's say a controller node, will get or subscribe the data from this topic. Then we have a master node. Name service for ROS helps nodes find each other. So this is some kind of like higher level node, and its function is to coordinate and manage other nodes of the robot. And the other things I think we already have discussed about this ROS core and something but we now run it and later we see that how it works. Okay, so what are the nodes? A node really isn't much more than an executable file within a ROS package. So if you see your package here, let's say if you want to see where the nodes are located, so just go to any package. Let's go to package that you have created, the one we created last time in the previous lab. So if there is a node here in this package, it should be in this folder. Let's say I make a node here, I make a file, C++ executable file, and then what this file does is that it takes it counts, let's say it counts from 1 to 1000, okay, and then it stops. So this will be my node, one of my node. There I can make several nodes here in this folder, src folder, or I can make several packages here in this src folder. So this is my package beginner tutorials. I can make also multiple packages, one for counting numbers, one for watching the time, and then third for maybe controlling the motor. So there will be different packages, and each can have their own nodes. So this is what it says here, just a executable file. ROS nodes uses a ROS client library to communicate with other nodes. So if two nodes want to communicate with each other, how they do that? Using ROS client library. They also use topics to communicate. Nodes can publish or subscribe to a topic. Nodes can also provide or use a service. So what will happen that when two nodes want to communicate with each other, so what they do, they can only do it using a topic. So between two nodes there must be a topic. If there is no topic, then they have to use special thing called service, where the nodes can directly communicate with each other without using topic. Then we have client libraries. ROS client libraries allow nodes written in different programming languages to communicate. So this is one of also advantage of ROS. You can use here Python, you can use here C++, and also you can also use Java also in a special way. You need some more additional configurations, but you can do it. So what this client libraries does, using these client libraries you can use multiple languages here. For example, you have a Python client library. Using this library you can use Python to program to make a Python using to make a node using Python. And then similarly we have a C+ client library. Okay, then we have ROS core. So this is the first thing. ROS core is the first thing you should run when using ROS. So whenever you want to use ROS, so you have to enter ROS core. This is equivalent to whenever you double click any program to open it. So the first thing you do here, for example, let's say here you type ROS core, you copy paste this command. Remember that whenever you copy here, don't copy this one here, this sign. Just copy the text after this symbol and then paste it here and press enter. So now our ROS core has been started. It means our ROS robot operating system is working now. So it says that you will see something like this. Yes, something like this. We have seen it here. So I think we have already discussed it in the previous labs, but we go through quickly here. So what you can see here, it has created this process master and ROS master URI. So basically this is a sign that your ROS is working well and it has been started. Okay. If ROS core does not initialize, you probably have a network configuration issue. So if you have any issues with your ROS core, it means you have to configure your network. How? You can follow this link, and there they have a separate tutorial how you can do that. If ROS core does not initialize and sends a message about lack of permissions, probably this path folder is owned by root. Change recursively the ownership of that folder with this command. Okay, in case if the ROS is not working and you already have configured your network, then you have to type this command. But for me it's working well, it's working fine without any further modifications. So I just skip to step number 6 using ROS nodes. Open up a new terminal and let's use ROS node to see when running ROS core did. Bear in mind to keep the previous terminal open either by opening a new tab or simply minimizing it. Okay, so let's open a new tab in the terminal. Just click on this add button and then we have a new tab here. We also have the previous tab here and this is the second one. Note, when opening a new terminal, your environment is reset and this .bash rc file is sourced. If you have trouble running commands like rosnode, then you might need to add some environment setup files to your .bash rc or manually resource them. If you remember that we, in the beginning, when we were making our Catkin workspace, then we told the ROS that it should always remember the path where our packages are located. So we did it one time only, and I hope that it will work every time. We don't need to every time tell the ROS where the packages are located or where our workspace is located. In case if you are having problems here, then you have to manually do that every time. For this, follow the previous labs, and in that lab I told that how we can do that. Okay, now ROS node displays information about ROS nodes that are currently running. The ROS node list command lists these active nodes. So let's just copy this command here and paste it here and press enter. So now if you can see this command, it displays the total number of nodes that we have. And now we only have one node. It's called, the name of this node is ROS out. Okay, this is a main node that manages other nodes to help find each other. This showed us that there is only one node running, that is ROS out. This is always running as it collects and log nodes, debugging output. The ROS node info command returns information about a specific node. So if you want to know further about a specific node, you have to here copy paste this command in your terminal and then press enter. And so what we did here in this command, we wanted ROS info about the node ROS out. So this is a command. You can replace it with any other node. For example, if you have a node named IR sensor, or if you have a node named, for example, DC motor, you can type it here using this command ROS info. You can get further information about this thing here. So let's see what we have here. So when we have typed this here ROS info about this node, so it says that node name is ROS out, then we have publication is this ROS out underscore AGG, ROS graph, messages log, subscriptions, services, these are the name of the services it's providing, contacting node here, and then finally we have some numbers. So this is how you can get information of any node. Now let's see some more nodes. For this we are going to use ROS run to bring up another node. Section number 7, using ROS run. ROS run allows you to use a package name to directly run a node within a package without having to know the package path. So this is a very useful command, and we shall often use it to run our executable or a package. So what you have to do is you have to type just ROS run and then the name of your package and then the executable node, okay, within this package we have. For example, let's see what the package that we have created here. So you remember this, in the Catkin workspace we have, in the src folder we had manually created a package called beginner tutorials. So in this package, although we don't have any executable or any C++ or Python code, but let's say if we have here any Python code and the name of the Python code is infrared node. So how we gonna do that here? When we want to run this infrared node, then we have to type here ROS run and the package name is beginner tutorials and then the node name is infrared node, and then type it here in the terminal and then press enter. Since we haven't made any executable node in our beginner level tutorials package, so we shall use nodes that are already there. Okay, for example, so now we can run the TurtleSim node in the TurtleSim package. So let's see where the TurtleSim package located. So this is actually a ROS package that has already some built-in. Go to other locations, then your computer, and then from here you have to go to OPT. Where is OPT? This is OPT, and then you have to go to ROS, Noetic, and then share. And then here you can, if you go to something like T, and here you will see some TurtleSim package. Here is our TurtleSim package, you can see. So in this TurtleSim package, you can see there are many subfolders, and these are some files it has. Then we have some images here of different turtles, and then we have CMake folder here. We have configuration files, and there must be some more packages related to this package. So this is this is a package, and in this package they say that they have this node called TurtleSim node. So we haven't found it. I don't know where it's located, this TurtleSim node. We have services here, we have messages types, but I couldn't find this TurtleSim node. Maybe it's not in the share folder. Maybe you have to go to libraries in here, and here you have to look again the TurtleSim. Here, yeah, go to TurtleSim, and here is, yes, so in this package we have this TurtleSim node. So remember this. So this is the ROS installation, and in this installation you have already some guy made a package called TurtleSim, and in this package he or she made a node using either Python or C++, and this node name is TurtleSim. Okay, and so what this node is, it's actually a C++ or Python code that you can execute. So how you're gonna execute? You type this command here, ROS run, then your package name, which is TurtleSim, and then your node name here. So just paste it here, and then you have to just press enter here, and you see that. So what this node does is it creates a simulation environment for a turtle. So this is a turtle. It can move around, it can move forward, it can rotate, and this is actually a two-dimensional simulation. So what this node here was, this node code, C++ or Python code, I'm not sure. Let's check it, what code it has. Okay, it's not mentioned here. Maybe some information is somewhere else, or we can just manually open it. Let's see with maybe. Okay, it's executable actually. It's not an actual code, but it's a binary code here. It's already been converted from your C++ or Python code to your binary code, machine code, you can say 1010. So yeah, so that's how we execute our ROS packages and the nodes inside the ROS. So this is our result. And here it also says that okay, you will see the turtle sim window. The turtle may look different in your turtle sim window, don't worry about it. So our turtle looks like same or different. Where is the turtle sim? Here, it's different, yeah. So he's right, because I think it randomly selects some different types of turtle, or maybe why. Let's read out why it looks different. There are many types of turtles, and your is a surprise, which they randomly select. You remember in the ROS packages there were images. If you go to Noetic share and then you go to your turtle sim here, and there we have images, and there we have different types of turtles. So I think this node randomly selects these kind of images and use them in your simulation. Okay, in a new terminal you have to type the rosnode list. Open a new terminal, and here copy paste this command rosnode list, which will show you now how many nodes active are there. Just press enter, and now you see that now there are two nodes that are active. One is ROS out, which is like a higher level node for robot operating system, and then we have another node called turtle sim, and the function of this node is to display a turtle on your screen. Okay, one powerful feature of ROS is that you can reassign names from the command line. Close the turtle sim window to stop the node, or go back to the ROS run turtle sim terminal and use Control C. So whenever any of your ROS node is running, you have to press the Control C and it will stop running. So let's see that. You can also just stop it from here, or you can go to this terminal where we started this node and press Control C, and now it's gone, it's stopped. If you want to make sure, now press again this rosnode list, and okay, it's still showing this node, but why we only have now one node? Okay, so this was the old, okay, this is the old one. You have to open a new one, and here you have to type rosnode list again, and let's see if we have updated or not. Oh, interesting, it's still showing two nodes. I think we have to end the ROS core also this time. Control C, and then run it again here. Okay, now again we see how many nodes we have now. Yes, so now the list are updated now. Okay, close the turtle sim window to stop the node. Now let's rerun it, but this time use remapping argument to change our node's name. So you can change the ROS node's name, but I think at this level we don't need it. But you only have to know that we can change the name of the node if you want, okay, using this command. If you ever need that, we shall come back here and then we shall try it again. Note that if you still see turtle sim in the list, it might mean that you stop the node in the terminal using Control C instead of closing the window, or that you don't have the ROS host name environment variable defined as described. Okay, so we were having this problem, so I think we let's find out what was the problem. So let's start this node again, turtle sim node, and you see this time there is a different turtle. And now let's check out how many nodes we have in the list. We have two nodes. and then this time we close the node using this cross button, and then we check again. So this time, yes. So it means that better to close a node using this cross instead of Control C. Okay, this is more like efficient and it updates the nodes quickly. Okay, so we see our new MyTurtle node. Let's use another node, rosnode command ping to test that it's up. Okay, so here what we do here, we try to communicate with this node, the node that we have created. The node that we have executed, and the node was rosrun turtlesim node. And let's execute it one more time, minimize it, and in another terminal window paste this command, but this time here you have to type turtlesim what was the name of this node? Turtlesim node, because here they have manually changed the name, but we haven't. Okay, so that's why we have to use our node. Okay, so node name is actually turtlesim. From here, yes, sorry, from here you can see the node name here. So let's try again. Ping and then turtlesim. So now you see we have now started to communicate with this node. We have started to communicate with this turtle. So it means that we send messages to this node, and it also sends us back messages, and this is the time that it takes. So this means that we can communicate with this node. So it means that we can move this turtle forward or up, down, or also rotate. So, but if we can communicate, then it means that we can control also this node. So let's do a little bit review. What we covered is, we covered ROS core, which is ROS plus its core service, master, and this ROS core actually provide name service for ROS, and it's also provide also these additional services. And then parameter servers will be introduced later. And then secondly, we covered ROS node, which is ROS plus node. It's actually a tool in the ROS to get information about the node. Okay. And then we learned about ROS run, which is ROS plus run. What it does, it runs a node from a given package. Okay, so this is just like double clicking any executable in Windows. Now that you understand how ROS nodes work, let's look at how ROS topics work. Also feel free to press Ctrl C to stop turtlesim. So here we have to stop it. The pinging, just Ctrl C, and here you can stop it. I think better stop it from your window directly. And also let's stop. Okay, don't stop ROS core. And now let's move to how ROS topics work. Okay, understanding ROS topics. This tutorial introduces ROS topics as well as using the ROS topic and RQT plot command line tools. So the first step is setup. Let's start by making sure that we have ROS core running in a new terminal. So yes, our ROS core is running. Then in the second step, for this tutorial we will also use turtle sim. Please run in the new terminal. So copy paste this command here in the new terminal, in the second terminal here, and press enter. So now we have this turtle sim node running. This is the node name here. And then in the third step, what you have to do is we shall also need something to drive the turtle around with. Please run in the new terminal this command. So in the third terminal, we enter this command. So what this command does is actually, you can see ROS run turtle sim turtle tally-op key. So this is a package. Again, this package is located in your ROS database, and tally-op, what was the name of package again? Turtle tally-op key. Yeah, this is a node name actually. So in the turtle sim, yes, in the turtle sim package we have also the second node, okay, executable. Let's go to this Noetic and then libraries, and then go to your turtle sim package. It's located here, and here this is our second node. So this first node, turtle sim node, it shows a turtle on your screen, and then this second node, what it does, it gets input from your keyboard, and then it uses this input to control this turtle, to move around this turtle according to your commands. So let's see how we can do that. So we just copy paste this second command and press enter. So now it says that use arrow keys to move the turtle. Okay, so where is our turtle here? So this is our turtle. Let's make it a little bit on this side. Okay, so now I will use arrow keys to control this turtle. Let's see, can I do that? Okay, now I want to move this turtle to move forward. Yes, so it's going forward, backward. Okay, if I want to move it, rotate this one, then you have to press the arrow key, the left or right, and then move forward. Then again rotate. So notice that whenever you press a left or right key, it rotates almost 90 degree, I think, yes, 90 degree rotation. So this is how you can control your turtle on your screen. So you see that if we can control this turtle, then it means we can control also a robot. Okay, this will be our tally operated simulated robot, you can say. And for this we needed ROS environment, and then we needed a code written in Python or C++ to make this node to display this turtle. And then we also needed a node which is written as in Python code or in C++ to get input from our keyboard, and then give this input to this our turtle node. And now we shall go deeper and see how this communication works, how ROS, in the ROS environment, this communication is going on. Okay, we shall see here further. Now that you can drive your turtle around, let's look at what's going on behind the scenes. This is important for understanding ROS, how it works. The turtle sim node and the turtle teleop key node are communicating with each other over ROS topic. So between these two nodes, one node here, turtle sim, and second node, the turtle teleop keyboard node here. If you want to see how many nodes are running, so again you have to go in a new terminal and type here rosnode list. So I think the spellings are not correct. Okay. So now we have one node from the ROS, which is a general node, which will be always be there. But there we have then two additional nodes. One is turtle sim. The function of this node is to create this display, the simulation or the visualization. And then we have a second node, teleop turtle, which gets input from your keyboard, and then it sends information data to your turtle. And so here the same is, it says here same thing, that so these two nodes, this teleop turtle and turtle sim, they are communicating with each other using a topic, ROS topic. There is no direct communication. Instead, we have a topic here. Turtle teleop key is publishing the keystrokes on a topic, while turtle sim subscribes to the same topic to receive the keystrokes. So what's happening here? Whenever you press your arrow key on your keyboard, so this the node, the teleop turtle node, it gets these data or information from your keyboard, and then it sends this these messages, okay, this data to a topic. We already studied that what is a topic. A topic is a memory, a temporary memory, where the messages or the data is stored here for some time. And nodes, different nodes can send data, which is publishing a data to a topic, and then some nodes can also receive data from a topic, which is called subscribing data or messages. So in our case, what's going on here, this turtle or teleop turtle node, it's getting your data from keyboard, and then it publishes on your specific topic, okay, and from this topic, the other node, which is called turtle sim, it's subscribing data from this topic, and then it uses to display the current position of your turtle on the screen. Let's use RQT graph, which shows the nodes and topics currently running. So there is one more command, it's called RQT graph, and you can use it to visually have an idea which nodes are running and which nodes are communicating with each other. It's better to visualize, okay, and for that you need this RQT graph. RQT graph creates a dynamic graph of what's going on in the system. RQT graph is a part of RQT package unless you already have it installed. I think we already have it. I think let's try it without installation. So you just have to copy paste this command here and then paste and then press enter. So I hope that it will work, because this is a latest version of the ROS. But I think for the older versions we need to manually install it. Yes, so see that this tool, this is another tool in ROS that is used to visually describe how nodes and how communication is working So let's maximize it first. And this is the graphical visualization of what's going on in our ROS environment. So we have one node, it's called teleop_turtle, and we remember that the purpose of this node is to get information from your keyboard, and the information like what keys are being pressed, and then this information is given to your TurtleSim node. And the purpose of this TurtleSim node was to display a turtle on your screen and then to show its location. And how they communicate is there is a topic between them, and the topic name is turtle1 CMD velocity. Or you can here select, here we have selected nodes only, but you can select here nodes topics that are active here. So now this is our node 1, which is our teleop_turtle, and then we have a topic here. And so what this node does is it takes input from keyboard and publish it in the topic, okay? And then the second node, which is TurtleSim, it subscribes data from this topic, okay? And it then finally shows the location of turtle. So these are the active nodes here we have. And if you can see all the nodes here. Okay, if you want to see also the ROS nodes, which are managing these all nodes, you can also click this, click on this leaf topics or debug maybe. Yes. So here you can see that this gets more complicated, the graph. Here we have our teleop_turtle node, then we have a topic, and then we have a second node that displays the turtle. And these other nodes, they are the actual ROS nodes that are used for management and coordination purposes. Okay, we have ROS out node, then we have a ROS out package, and you see that all the nodes that we have manually created or someone else manually created, they are connected or they are communicating with the main ROS core or ROS out node. Okay, and because this is a major node that helps to coordinate between all the nodes. Okay, now you have visually seen that how this works, and let's now close this one. If you place your mouse over, okay, I think we have already covered it. It will highlight the ROS node and topic. As you can see, the TurtleSim node and the turtle teleop key nodes are communicating on the topic name turtle1 command velocity. So we have already covered it. Now let's move to 2.2 section, introducing ROS topic. The ROS topic tool allows you to get information about the ROS topics. If you see in the last time we studied ROS nodes, how to get detailed information about the ROS nodes. We have seen some tools and commands, and now for ROS topics. You can use the help option to get available subcommand for ROS topic. For example, if you type this command here, then press enter. Let me first minimize this one. Okay, if you forgot any command, let's say if you forgot any command, then just type ROS topic -h, and then it will give you some more option. For example, ROS topic BW, and this command, what it does, it displays bandwidth used by the topic. Then we have a command called ROS topic delay here, and this command displays delay of topic from timestamp in header. And then we have a command called ROS topic echo. This command is useful and commonly used command, and what it does, it prints messages to the screen. So from your topic, if you want to see what kinds of messages are being published, so what you have to do is to type this command. And then you have a command called ROS topic hz, and this command, what it does, it displays publishing rate of the topic, what's the frequency. And similarly, we have ROS topic info, which prints information about active topic. Then we have list. If you want to see how many ROS topics are there, you have to just type this ROS topic list, and ROS topic publish data to topic. If you want to manually publish some data to a topic, you can also do that using this command called ROS topic pub. And then finally we have a command called ROS topic type, which print topic or field type of your specific topic. So now we have seen different commands, and let's now try to apply them. Remember that we are running this turtle sim packages and nodes, and what you can do, you can now try to explore what's going on here. Let's start with ROS topic echo. This command here, ROS topic echo, is then the topic name. Okay, so first I shall see what topics are being published. For example, ROS topic list. You can see here these topics are being published now. Like we did same with the nodes, how many nodes were being published using ROS node list. Similarly, you can do with the ROS topic also. And then you can select any of these topic. For example, let's see what's being published on this topic, turtle 1 CMD velocity. So just copy paste this command here and paste it here and press enter. So it's getting slow because of the virtual machine. Now it's getting slower. As we run more simulation, it will get slower and slower. Or it means that maybe nothing is being published. That's also a possibility. So now what we do is we try to detach this terminal and make a separate terminal here. Okay, and now we go back our this Teleop key node, and here we try to press any button. Okay, it's not Control C, and then we again run this node, ROS node, turtle sim node, and from here you can control your turtle. Okay, so note that when I press any key here, why the turtle is not moving. Okay, sorry. So this was a node. This was for I'm using a wrong one. So this is for turtle sim node displays a turtle. Okay, to control a turtle, we need to use our second node, which is called the turtle teleo keyboard. So here, when you come here and press your arrow key, you see that you have also, there is on this topic, there is a data that has been published on this topic. Let me make it more presentable. Okay, so what we did, that we use this command called ROS topic list, and there we said we found a couple of topics that are being published, and now we are interested in what data is being published in this specific topic. So we use this command ROS topic echo and then the topic name, and then what we did, we came back to our this keyboard control node, and then we press an arrow, let's say this time the left arrow, and you see that in this topic this data has been published. What this data says, that z-axis you have to move with 2 velocity or something, and when we press now I press the front arrow, sorry, not here, if you come back here and then press the front arrow, and this time you see the linear x-axis, there is a data has been published on this topic, and this data from this topic is received by this turtle sim node, which moves the turtle accordingly. So in this topic we have linear motions and also angular motions, and whenever you press any key, so that specific data will be published on a specific topic, and this will be subscribed by your node. Okay, now let's look at RQT graph again. Press the refresh button in the upper left to show the new node. As you can see, ROS topic echo shown here in the red is now also subscribed to the turtle command velocity topic. Okay, let's see. Let's open a new tab in the terminal, and here we type, what was the command, ROS run RQT plot RQT plot. This is for visualization of our nodes. So what we are expecting is something like this here, because now there is one more. Okay, now we have here. I think I have entered a wrong command. Let's see what was the name of this command to plot the nodes here. Where was it? RQT, no, sorry, not plot, it was graph. Okay. Plot is for plotting your data in real time or plotting a graph, but this is for visualization of the nodes. Okay, so here is this was our teleo turtle node that gets the data from the keyboard, and then this is our topic, and previously this topic was being subscribed by our turtle sim node that displays a turtle on your screen. But now we have also created another terminal for, you remember, for here we said, okay, we want to show the data that has been published. We want to show this data on your terminal. So we use this command called ROS topic echo and then the topic name. So it means that now we are also subscribing to this topic. We're also getting data from this topic, and this is being shown here. So here is a topic, and this topic is subscribed by this terminal, a new node, ROS topic echo, and the purpose of this node is to show data on your terminal that is being published on this topic. I hope this is clear now. Okay, using ROS topic list. We have already done it. ROS messages using ROS topic type. Okay, ROS messages. So what are the ROS messages? We have covered now ROS nodes, then ROS topics, and then finally we shall see now what are the ROS messages. Communication on topics happens by sending ROS messages between nodes. For publisher, turtle tally-up key, and the subscriber, turtle frame node. To communicate, the publisher and subscriber must send and receive the same type of messages, or the same type of message. This means that a topic type is defined by the message type published on it. The type of the message sent on a topic can be determined using ROS topic type. So whenever you want to communicate between two nodes here, again I execute this to show you how this works. So if you see that these two nodes, turtle, tally-up turtle and turtle frame node, they are transferring data from this here to here. So this node is getting data from this node through this topic, which is turtle1. So what kind of data it's using? So they are they are passing the data using messages. They are sending messages to each other. So this tally-up turtle node send message to this topic, and then the topic send message to this turtle sim node. So there are specific types of messages. For the nodes to communicate with each other, it's important that they must have same kind of messages to communicate. Otherwise, they will not understand what type of message is this. In the ROS, you have specific types of messages. Okay. For example, if you want to see the type of your message, then you have to copy paste this command here, and then paste in your terminal here. I stopped the previous one here. So it shows that the messages are the type of geometry messages and twist. So this is a type of message. If you see also in the data, you have a specific format of the message. You see there is a section for linear and then angular velocities, and this is a data type of your this is called the geometry or the twist messages. So both nodes should be able to, along with the topic, should be able to communicate with same data types. Otherwise you need some kind of conversion between them. You can look at the detail of the message using ROS message. So if you want to further see the details of this message, you just copy paste this command from here, and then type it here in your terminal and press enter. You see that in our topic, that was turtle1. So what kind of messages it publishes. Geometry messages, vector 3, linear. So it has a float 64x, float 64y, and similarly z. And then we have geometry messages, vector 3, angular. It's also float 64. This is data type we have. So both the nodes and the topics, they must have same kind of data types. Otherwise, they will not able to understand each other. Okay, using ROS topic publish. You can also use this command called ROS topic publish, and what this command does is that it manually publish any data on a topic. Okay. So for example, we can use this command here, this second one here. Copy paste it in your terminal. So also remember the location of our this turtle. Okay, now I paste this command here and press enter. See that the turtle moved accordingly. So what we did, we said manually to this turtle that move to this location 200 and 001.8. So it has accordingly moved in this location. If you make all that like 00 everywhere, let's try this also. Let's say this is 0.0 and make it also 0.0. And now we press enter. Okay, so it's not actually the location, it's the velocity command. Sorry, yeah, it's a velocity command along the linear and the twist along the rotational axis. So I think first one is the linear. So along x-axis you have to move, let's say, with the velocity of 2, and along the z-axis, let's say you have to move with velocity of 1, and press enter. Now see that the turtle moved again, but this time a little bit, and let's make it bigger. Let's say make it 5. Okay, so these are the velocity commands that we can use to publish. So if you now see the RQT plot, or should I? Yes, ROS run RQT plot here, let's say. RQT graph, sorry. If you see that, I show you that where the data is being published. So what we are doing is that here, whenever we want to publish, we use this ROS topic pub command. What it does here, it creates a node here, and then it publishes a data here. Okay, so what it does here is it creates a node temporarily, and then it publish on this topic the command, okay, for manually moving the turtle, and then this topic it then publish on the turtle same, and then the turtle moves accordingly. This is how it works. You can try also some different combinations to move around your robot in linear and angular directions. And then what it shows here, we can also look at what is happening in RQT graph. Press the refresh button in the upper left. The ROS topic PUB node here in red is communicating with the ROS topic echo node. So yes, that's what I was saying here. So this was a topic, and this was a echo node. Sorry, the publication node that was sending data to your this topic, turtle1 topic. That was a manual data, you can say, transmission, or publication is the better word, yeah, publication and subscription. As you can see, the turtle is running in a continuous circle in a new terminal. We can use ROS topic echo to see the data published by our turtle sim. Okay, so you can use this command here to see what data has been published. ROS topic echo. This is another topic. So this is the x coordinate, and then this is the y coordinate of the robot, and this is the orientation or the angular position of the robot. And then we have linear velocity, angular velocity here. So if you move your turtle with your keyboard, so you can see here its position orientation changes accordingly. So let's try to move it in this direction. So you can see in this direction x will increase and y will also increase. Notice this x and y here. Four, 9, 6, 10, yes. So if you move it in one direction only, let's say move it downwards, then y should decrease but x should remain same. So notice here, y should decrease but x increases a little bit because I cannot make it like perfect right angle. So yes, here you also can see the orientation, the theta, and I think it's in radians. So when I move it 90 degrees, then again 90 degrees, you see the angle changes, the orientation of the robot. And then we have linear velocity and angular velocity. When you press the back arrow, you see that the maximum linear velocity backwards is 2, and same is for forward. And then when you press right or left arrow, right arrow let's say, then you see the angular velocity on the clockwise rotation is -2, and the angular velocity for the anti-clockwise rotation is 2. So this is how the communication between the different nodes work. So ROS topic HZ. ROS topic HZ reports the rate at which the data is published. So it tells you what is the frequency of data publishing, after how much data is published per second or something. So we use this command here, and then we paste it in your terminal. You see that if I now press this keyboard, see that the average date of publication is 60, almost 61 point something. It means that per second we have almost 61 messages in each second that is being published on this topic. So this keyboard node, it gets data from the keyboard and then publishes on the topic 61 times each second. And then we have this turtle sim node. It subscribes data also, like 61 times per second. Now we can tell that the turtle sim is publishing data about our turtle at the rate of 60 Hz. We can also use ROS topic type in conjunction with ROS message shown to get the depth information about the topic. So now let's type this command here. We stop it using Ctrl+C. We type a new command, then press enter. So yes, again it shows the data type and how the structure of your message, which is being published on the on your topic. Okay, now we see how we use rqtplot. So previously we learned a ROS tool called rqtgraph, which shows the connection between nodes and topics in a visual graphical form. And now we learn to use rqtplot. This is a same function that we use sometimes in MATLAB or other. The purpose of this tool is to plot your data. rqtplot displays a scrolling time plot of the data published on topics. Here we shall see rqtplot to plot the data being published on the turtle post topic. First, start rqtplot by typing this command. So what this rqtplot does is it displays your data in a graph form with respect to time. So just run this command using rosrun, and then we shall see. So this is your graphical window, and here now you have to give a topic that you want to display the data. And let's see which topics we can give here. In the new terminal, in the new window that should pop up, a text box in the upper left corner gives you the ability to add any topic to plot. Typing turtle1 pose X will highlight the plus button previously disabled. Press it and repeat the same procedure with the topic turtle1 pose Y. You will now see that turtle's XY location plotted in the graph. So let's try it. So here you have to give your topic name, and then you have to click add, and then again you have to give a topic name, this time Y coordinate, and then you have to add. So now it's showing data of the position of your turtle robot in X and Y coordinate system. Okay, so where is the blue line here? Let's try to minimize it. And now I shall try to move the robot using the keyboard commands. See that the X and Y positions of your robot that are published on the topic, now they are being plotted in real time. So now the X coordinate is decreasing. Now this should be same. So here X and Y should be approximately same. So X and Y should be 0, 0 almost. Okay. So now as I move in, let's say in this direction, you see both the x and y, they are increasing, but y is increasing more. So now my turtle is from y-axis, it's almost 5 point something, 5.8, and on x-axis it is 3.8 or 9. So this is the position of your turtle board in real time, and you can display. Similarly, you can display any data on that is being published on any topic. Okay, so right now we have only one topic, and its name is Turtle1, and this topic has further data types, and now we are using 2 of them, and we are displaying them here. So I think we have we shall finish this lab session today, and in this lab session we have learned today about the ROS nodes, we have learned about ROS topics and messages, and also we learned about how we can visualize the data between the data that is being published on the topics. And we also seen the communication structure of how a robot operating system works. And this is a basic example of, and later you will manually create your own nodes, and then you can publish, you can communicate between them. And yeah, so thank you very much for staying with me. I hope that you learned something new, and we shall again meet in the next lab session.